Good morning, good afternoon, whenever you're tuning in. If you missed the lesson, thanks for being here and catching back up on your work. We're going to be talking about 8.03. We're going to upload some notes, which includes things that you put in your notebook, take a picture of it and submit it. Also, things in Desmos that's going to serve as our notes as well. So you're going to have to do the notes in the Desmos and just kind of follow along with me. We're going to be analyzing the graph of a function f, and then we're going to use that graph to make claims about f prime, its derivative, the derivative graph of that. So kind of maintaining this relationship between f and its derivative, right? Slope, instantaneous rate of change at any point on there. So if you want to think just kind of really briefly about what we'd be doing here, right? Think about a graph that is constantly changing, right? Sorry, I shouldn't use the word constant. That is, its rate of change is changing throughout. Right? The rate of change is never staying the same. So the slope here is different than the slope here, which is different than the slope here and here and here and here and here and here, right? So on and so forth. And we can see that these graphs, the slope starts off as very positive and it stays positive until it gets to the top. And when it flattens out, and then it starts to become negative, and then it starts to get very negative. Somewhere in between, it gets perfectly flat and has a slope of 0, right? So if we were to take these slopes and to graph their values, we would say, okay, at whatever x value we have here, it's a very, very positive number. All right, so maybe it would be like very, very positive. And then as we get to this x value, it's still positive, but not as much. And then when we get to this x value, it's not positive at all, it's 0. And then it's going to be negative and then really negative, right? So on one graph, we could actually find the slopes, and on the other graph, we can actually graph the slopes. That would be the graph of f prime, the graph of basically the slopes. Okay, and that's what we're going to be doing today, is basically taking one and sketching the other based on some key characteristics. So let me clear this and let's get on to it. Let's take a look at some key annotations for today. Yep, just remember secant line, tangent line. And here are the first pages of our notes. So we're going to start with just some kind of quick 2-column notes where we're going to be talking about f, the original, okay, and f prime, the derivative. I'm putting this as parentheses, not to say like f derivative. It's just kind of an annotation to myself to remind myself. And remember that this is going to be like the graph of the slopes. Right? We're actually going to have an entire graph that is relating the slopes of the original function. So it's going to be talking about the slopes, graph of slopes, I should say, of f, right? Instantaneous rate of change of f. All right. So if we see on our original graph that the original graph is increasing, well, what does that tell me, right? If our graph is going up, our slope must be positive. Right? An increasing function means a positive slope. How would I see that on a graph? And I know this is very basic, but we know that increasing means going up. So if I see my f graph as going up, we know that it's going to be positive, the f prime graph. All of those values are going to be above the x-axis. And conversely, if the graph is decreasing, right? So let's say, that means that the slope is going to be negative, let's say. And all of those negative values, if I were to just have a negative value and put it on a graph, let's say the slope was like -4 at some point. Well, where's -4 on the graph? -4 is going to be below the x-axis, right? So these are two separate graphs. And we'll show kind of what that looks like graphically in a bit. And then, of course, I should say going down for this one. These are just annotations to myself to make sure that I'm not confusing and that I am separating, the distinction between decreasing and a negative slope. Okay, what else do we need to know? We also need to know, okay, if the original function has a maximum or a minimum, and you may remember from the picture before, a maximum, right? I'm going to draw a picture for us, would look something like this. That would be its max, its local max, or its relative max. And we know that we have a maximum when we go and our original graph changes from increasing to decreasing, right? It goes up to goes down. If it changes from increasing to decreasing, there must be a little bump there, a local maximum. And if that happens, what is the slope going to be at that maximum? Think about the slope. Well, the f prime value, the slope, is going to be 0. What does it look like when I graph a y value of 0? What that looks like is we're going to have an x-intercept. And it's going to be changing. We know that not only is it going to be 0, it's going to be changing from increasing to decreasing. So that must be going, not only crossing the x-axis, but it's going to be crossing from the positives, increasing, right, positive slope, to negative, decreasing, crossing from positive to negative. And then finally, our minimum values. If our original graph is a minimum value, right, bottom, lowest, we still know that what's going to happen here is even for a minimum, the slope is still going to be 0, right? So for each one of them, they each have a slope of 0. The f prime is going to be 0. And for each one of them, that results in an x-intercept, or it crossing the graph, f prime crossing the axis. But what's different for a minimum is that it changes from decreasing to increasing, which is an important distinction because we're going from negatives to positive on our graph, right? Which is on our graph, or our f prime graph, if we're going from negatives to positives, we're going right from below to above. These are those distinctions that we want to make. Now, what I'm going to have you do later today is I'm going to have you make some claims. You're going to have to look at a graph. Let's say, you know, an f graph, an original function graph. And you're going to have to notice, okay, what is happening if my original graph is increasing? What will that then tell me about my derivative graph? What would that look like on its own graph? Or I could ask you, if a derivative graph, let's say it has a slope of 0, what would that tell me about the original function? What must be happening on that original function? So there's this back and forth relationship where you're using this chart to kind of allow yourself to make observations on one to know what the other is doing. Okay, and what I'm going to do, I kind of like a picture of these notes. They turned out better the second time around. I'm going to take a picture of them. Thanks. And now we're going to go practice using these notes. So I'm going to go to Desmos, and you should too, to copy down exactly as we are doing. Let me start my share. And you would be doing slide number 2, right? Slide 2 of 10 is like the notes problem. So let's kind of break one of these down and let's use our chart. So we are given the graph of f of x below. That's important because that tells me that we're talking about the original graph down here. Okay. Use the key features of the graph to answer questions about f prime. F prime, we must be talking about this graph's slope, right? So given f, we want to talk about its slope. We want to talk about what's happening to the derivative. So when is f prime positive? Well, I need to just use my chart. And I can see that f prime is positive when f of x, going backwards, is increasing. Right? When f of x is increasing. So we got decreasing. At -2 to 1, it increases. That looks like a straight line, but it's supposed to be curved. It goes back to decreasing. And then 3 to 4 is also increasing. So when is f prime, the derivative, positive? Well, that's going to be when f of x is increasing. So we don't want to include all of those points. We want to use intervals here. So say from where to where. So remember that we use x values for interval notation. So I'm going to say f prime of x is positive, flipping the script here. When, or sorry, I'm going to say on to indicate an interval, -2, 1. Notice that's not a point. That's actually just telling me my x values, right? -2 to 1. So it takes some kind of reading to be able to decipher that that's an interval. So it's positive on -2, 1, and what else? 3, 4. And now I want to justify. How do I know that? Because I've made a claim about f prime. I'm going to justify it with evidence from f, because that's the graph I have. Because f of x is doing what? Is increasing on those intervals. That's it. That's all I got to say. So it's relating, basically, if f is increasing, f prime must be positive. We have a positive slope in those situations. If I take the slope of any single one of these points on those intervals, it's going to be a positive number. It's essentially what we're saying here. What about negative? Is it possible for f prime to be negative? Well, sure. And we look at our notes and we see f prime, the derivative graph is negative, work backwards, if f is increasing, or sorry, decreasing. So when it's going down, we got one section going down there, and we got one section going down there. Each one of these is decreasing. So let's just put this on f prime of x is, what are we talking about? Negative. On what intervals? Once again, we're just going to use the x values. So it starts decreasing at -3 to -2. And where else? From, let's see, my purple here is my decreasing from 1 to 3. So I'm just using x values when I talk about interval notations. Those aren't points. That's telling me from x equals -3 to x equals -2, and from x equals 1 to x equals 3. It's negative there. F prime is negative because, well, how did I know that? Because f of x is decreasing on those intervals. And if I take any one of these points and I find the slope of any one of these points, guess what they're all going to be? All of those slopes are going to be negative, right? That's what the question is asking me, saying, when is the slope negative? So we don't want to include all those points. That's why we write those intervals. All right, finally, when is f prime of x equal to 0? So there's two options, right? If we look at our notes, f prime of x is equal to 0. F prime is equal to 0 when we have a maximum or we have a minimum, when we have that vertex, a local or relative extrema. Let's see. That's going to be here, here, and here. Notice how if I take the slope at those points, the tangent line at those points would be exactly flat. What's the slope of a flat line? 0, right? That's what it's asking me. When is the slope 0? When is this going to get flat? And that's going to be at these maximums and minimum values. So now this time I don't want to use interval notation because it's happening at an instant. So it's happening at x equals -2. X equals 1 and x equals 3 because, and how do I know that? How do I know that again? Because what's happening to f of x there? Now I could say f of x has a maximum or minimum at those values, but what I'm going to say instead is because f of x is changing from increasing to decreasing or decreasing to increasing at those x values. Right? Decreasing to increasing, anytime we have that change, we have a vertex, therefore a slope of 0. Increasing to decreasing, vertex, slope of 0. Decreasing to increasing, vertex, slope of 0. All right, that's what I was asking for. Those are my justifications. These are exemplars. This is what I would ask you to use as your reference when you're trying to justify and make claims, right? Justify what f of f prime is doing by what f of x is doing. Now, if you want to go one step further, you would be actually making a sketch of f prime. So actually graphing all of the slopes, right? So this is just going to be a graph of f's slopes. So basically, if I were to take every single point here, find its slope at that point and graph its slope, we would have a certain graph. Well, let's see. Easy things to graph are when f prime is going to have a slope of 0. Well, let's graph all of those. We're going to have zeros at -2, 1, and 3. So f prime, the slopes are going to be 0 at -2, 1, and 3. And then let's see what else we know. The graph is decreasing from -3 to 2. So that means that we have negative slopes. Now I could actually try to calculate each slope in there and estimate it. But basically what I need to know is that we're starting in the negatives with my slope, getting to a slope of 0. Right? So we start from negative slopes, slowly approaching a slope of 0. Now, we get into positive slopes. What happens when we have positive slopes? Well, all of these are positive numbers, right? These are positive, these are negative. That's why I started down below. And if I have positive slopes, all of these in the red are now going to be above the y-axis because all of these slopes are positive numbers. I have a very small positive, and then my positives get larger because my slope starts to increase. And then my positives get smaller again, because if I take the slope way over here, that's going to be close to 0 again. So what that means is I have positive values, my slope is changing. I get a very, very high slope, positive, and then it kind of goes back to a slope of 0 right here. Now what happens? We have negatives, right? It starts decreasing pretty slow, then decreases fast, then decreases slow again. So all of those are going to be in the negatives, and it's going to come back to 0 at 3. And then it's going to be back into the positives from 3 on. Now, I know that looks kind of crazy, but once again, what did I do? I basically took the slopes on each one of these, and I just graphed the slopes. If it was decreasing, right, maybe I can color code this to be the same. Decreasing meant below. So I put a purple down there. Decreasing over here meant below. Increasing meant positive, above. And anything that had a maximum or minimum, a derivative of 0, meant, well, we were going to have a 0 there. So there's that relationship between one versus the other, and how we can go back and forth between derivative and original graphs. And we can answer questions basically, if given one of those graphs, we could really answer questions on the other based on that relationship. Go ahead and submit those notes. And I'll see you in class.